like a couple minutes?
No. Okay, so I'm turning it on. You should have seen a pop-up that says we're live streaming.
And is it recorded too?
Yes, yes, we are live now, and I'm gonna let folks in like 1 minute. All right, it's 11 o'clock, and I'm gonna let everybody in. It looks like a few other people are coming in, so like maybe let's give it a minute. Sorry, that contradicted what I said a minute ago.
Welcome, everybody. We'll be starting in a couple minutes. Okay, I think that we can start now. So welcome everybody to this session of the 2023 LD4 conference on linked data. The title of the session is WikiframeVG, a SPARQL template-based Wikiframe for Wikidata graph exploration. Before I introduce the speakers, I want to point your attention to a few useful resources that you can see in the screen right now. Please take some time to review the conference code of conduct. If you have any technical issue, you can find tech support on the Slack channel, hashtag 2023-conf-help. And if you are not on the LD4 Slack yet, you can use the Slack invite link that Christine has put on the chat. The channel for the conference is hashtag LD4_2023. This session is being live streamed to the LD4 YouTube channel and recorded and will be saved on YouTube for future viewing. Please add your questions on the Slack conference channel and we will try to address them at the end. And now I'll introduce our two speakers. Darnell Melvin is the Special Collections and Archives Metadata Librarian and an Associate Professor at the University of Nevada, Las Vegas, where he is the lead metadata and semantic web strategist responsible for managing metadata activities such as large-scale remediation projects, metadata workflows, and metadata documentation. He is co-author of linked data for the Perplex Librarian and researches metadata and resource discovery in digital libraries, ethical representation in public knowledge graphs, and data integration. Darnell also teaches metadata architecture at the University of Denver. His work explores linked data implementation, metadata remediation tools and services, workflow engineering and optimization, and system interoperability. Darnell received his MLIS degree from San Jose State University with a specialization in information organization, description, analysis, and retrieval. Andre Hewlett is a developer and metadata librarian with over 20 years of experience in software development. He holds a Master in Library and Information Science degree from San Jose State University. His interests include information search and retrieval, metadata architecture, semantics, and linked data, and solutions for making LAMP resources more easily discoverable and available online. Darnell and Andre, please take it away.
Thank you. Let me go ahead and share my screen. We're going to do screen number 2. All right. Good morning, everyone, and thank you for attending today's session. I'm Darnell, Wikidata project lead here at UNLV Libraries, and presenting with me is Andre Hewlett, the application developer for WikiframeVG. In this session, we will introduce the Wikiframe visual graph, discuss the project scope, describe the system's architecture, and conclude with a demonstration of the user interface. For those of you who are still on Twitter, why don't you go ahead and tweet at us using @metadataguy and @AndreHewlett using the hashtag LD4_2023. Lastly, the slides can be found in the scheduler. So let's jump right in. You know, there's been a long history within semantic web research regarding the lack of ease of use and the mass adoption of linked data technologies. Some known barriers which prevents mass adoption includes 1, a lack of expertise in RDF modeling and writing SPARQL. 2, implementing this technology requires knowledge of the semantic web stack. 3, implementation requires subject domain knowledge because different research communities may model RDF differently or use completely different ontologies. And 4, there's still a lack of tools for linked data discovery and visualization. And on this slide, you'll see there's some references which discusses these challenges. And the reason I selected these articles was just to demonstrate how this problem has been with us since the beginning of RDF library linked data. So to give you a little bit about the project scope, this idea for this project came about after talking with some of you at the 2021 LD4 conference. There I presented what came first, the SPARQL or the egg, managing SPARQL-informed Wikidata productions for special collections and archives. Recommend for those of you who didn't see that presentation, go back and take a look on the LD4 YouTube channel. But after having some informal conversations with you guys, we came to the conclusion that we wanted to, 1, create a visualization tool that utilizes publicly structured data, so linked open data. We wanted to build it using open source technologies, and we wanted to create an environment where no SPARQL experience is needed. And lastly, we wanted to build it, govern it, and sustain it as a community of practice. Now that you have a little background on this project, I'm going to turn it over to Andre so he could discuss this visual graph.
Thanks, Darnell, and thanks everybody for your interest in our project. Can everybody hear me okay? Darnell?
Yep.
Good. All right, well, I want to start with the question, what is a template? Because the title of our presentation talks about SPARQL template-based implementation. So what exactly do we mean by that? A Wikiframe implementation begins with SPARQL templates. Simply put, templates are a set of SPARQL queries that define a data scope for an application theme, such as the theme for GLAM data, one that includes collections, oral histories, people, and corporate bodies. Now, if you like what you see here today, but think, well, I want to create my own, my own version of Wikiframe, you would start by defining templates for your copy of the Wikiframe codebase. So a Wikiframe template creation process is 3 steps. That's a kind of recipe for retrieving and showing your own Wikidata that involves the stored SPARQL queries, data mappings, and the resulting source code adjustments that you're going to need to make. Now, for our prototype, we did use the GLAM metadata theme. And you could use our theme as is just by setting a new scope filter, which I'll explain in a minute in a little more detail. Or you may want to make modifications to suit your needs. You may have an idea for a new theme, such as faculty profiles and academic networks. In either case, you create templates to guide your work. Next slide, please. So now that we've talked a little bit about what a template is and how it drives the whole process, let's talk about the system architecture. As Darnell mentioned, we chose open source and free software technologies to build WikiframeVG. So it would support our own efforts to make Wikiframe open source and community developed. And we use MySQL for the application backend. It caches Wikidata. And I'll talk about that a little more in a second. And then it holds configuration tables for the application. Django is really the big engine of the application. Django is a web framework that's programmed with Python, so all the application logic is really contained inside Python files running inside Django. And then we have some JavaScript for rendering our graph views. And then the web pages themselves are also produced by Django. Lastly, we do have some Python utilities that help with implementing application security and data management. Now, we've got some initiative goals, and I want to go over kind of where we're at with them right now. First of all, we wanted the application to be fast. If you run queries directly against the Wikidata query service, they can be slow. And the query service wasn't really designed for high transaction volume that would be created like this application. So we wanted to be easy on the Wikidata query service by caching data nightly or whenever it's needed, and then using that cached data to actually run the queries. We also want this application to be configurable, and this goes back to the template idea. We want people to be able to, easily update those data mappings that are required and use those data mappings to update the source code. We want that to be as simple as possible. We also want it to be flexible, built in a modular fashion, so that we can swap components in and out in the future if necessary, as part of the community collaboration process. So though we have some more work to do, it's still very much in a prototype state, all the source code, but some of the required features are definitely in place. And once we get them more fully in place, then Wikiframe becomes reusable by the community. And that, of course, is kind of the greatest objective that we have, that we can continue to develop the solution and make it better and better and more broadly applicable together. Next slide. So I'm going to dive into the data architecture a little bit more. So MySQL, as I mentioned, it's got the cache tables that come from Wikidata via that service, which runs outside the application. There's a nightly caching utility that that can be run on a cron job on a schedule that pulls the data into the back end as needed. You can also run it from inside, like an administrator can run it from inside Wikiframe using a special utilities page. So it gets the data, caches in those tables. There are also configuration tables that are used by the application that, among other things, hold the filters in the say SPARQL. Currently, this process takes about 30 seconds to retrieve and cache about 5,000 Wikidata entries for UNLV. So before Wikidata are retrieved, Wikiframe uses a filter system to insert specific values into the SPARQL queries to control the organizational data scope. I talked about the data scope around the template. I mean, you can think of that as the data scope for the theme. What types of information do you want to come back, and how do you want that information to be organized into collections and oral histories, for example? Well, the filtering system allows you to control the organizational scope. So you get the organization data just for UNLV, and that's what the application currently does. So how we do this is that our prototype uses the on-focus list of the Wikimedia project property P5008. And UNLV has a Q code that goes with that property. And Darnell and his team have applied that property and code to all the Wikidata that they've put in for archives and special collections as part of the PCC program. So it makes it very simple to pull back those 5,000 entries that it currently does. Now, if you're also using P5008 as part of your Wikidata, metadata management, you could use the prototype right now with your own organizational data scope simply by going in and changing the filter. So how the filter works is that at runtime, there's a filter tag. It just has a name that the system uses to know what to do. So you place the tag in the SPARQL statement. And then what happens is at runtime, Wikiframe finds that tag and replaces the tag with the specific property value. And then it runs the query and brings the data back. So, like I said, you could use this as is, or you could also write your own filters to really accomplish the same thing with different types of properties if you've had different methods for kind of establishing your organizational scope for the Wikidata that you've been entering. Next slide. So I want to talk about the kind of, upper half of the application, the site architecture and the user experience. Python Django, as I said, is controlling, most of the logic, and it does so with three main components. One is a component that does real-time querying to Wikidata, so it is capable of that. And it's currently bringing back data for charts, images, and item details. Then there's the search engine itself, which is using the cache data. The search engine also drives the graph rendering module, producing JSON, and then passing that to the graphing engine. For you graph heads out there, it's Viz.js is what we're currently using. And then, finally, those web pages are rendered. And as part of that, there's an application security utility that automates some of the maintenance of security that comes with Django. Django has very robust security as it is, but we wanted to automate this one step to make it easier for organizations to adopt the app. So when we look at our user experience, you'll see here in a second that it's organized by the theme's main classes. So in our case, the four main classes of the GLAM theme. And then there's also a search by subject page where rather than starting with a particular class of data like collections, you can go to search by subject, search for subjects within Wikidata that are relevant to the UNLV scope. And you can choose as many of those subjects as you want to submit a query currently to the collections class. And it brings back collections data and grasps all the relationships between those results. So, the charts and images are are meant to give direction on things to search for and just to provide some more context for the scope of our data. And then finally, you'll see that the app keeps track of your prior 3 searches. There's a history queue feature that that keeps track of your searches as you do them, because sometimes when you're interacting with doing keyword searching and then node form searching, so you can do it either way. You're like, hey, wait, how did I get to those results that I wanted to save? And the history queue kind of facilitates you being able to go backward in time to rerun that query. Next slide. So just a final takeaway before Darnell shows you the ropes, that all these queries, no matter what query you run, you always get a list view and a graph view. So you always have that context. So our goal with this is to really leverage the value of that visualization and allow users to see more relationships in the data than they could ever see just looking at a list, no matter how well searched they are with keywords and key phrases. And with that, that's the overview. And next up is the demo.
All right. So to access the demonstration, you could go to the address on there, but I recommend please don't use the service yet until after the demonstration. I don't want it to crash in the middle of the demonstration. So we'll turn our attention to a short demonstration to the Wikiframe. So here's the front page of Wikiframe. It's just a prototype. It could look a lot better, but here it is. At the front page, you have a little bit of introductory information about the project. To the right, you're seeing, I guess, ring charts dealing with our statistics. The first one on the top deals with a count of all the different entities that we've made in Wikidata. You can see our photo archive. We have a complete record. There is one record for every photo archive we have in our collections. So that is probably the most, probably followed by humans. And that is just by, this is live SPARQL. So if our Wikimedians started making new entities right now, and if I refresh the page, I mean, it's contingent upon the how long it takes to update on the cache on the Wikidata server. But if you hit the refresh page, say like 5-10 minutes later, you would see a change. So that's dynamic based off of SPARQL that I've written. One of the best ways to start is just by the search by subject. We could do a search of, say, water. And so in the results, you could then select what you would like to retrieve. So let's say water supply, water conservation, water management, water level, water footprint. The Las Vegas Valley Water District probably want that. We don't want the Tonopah Tidewater Railroad. This popped up because of the water match. So we don't want that, but we may also want water rights. So after I click that, we click the Retrieve by Selection button. And there goes the graph. And this is a very good way to show the initial grand overview of this stuff. If I want to show a lot of nodes, you could, but this will also show how nodes are interrelated. you can see the water conservation. These 3 collections now are dealing with water conservation. So you would be able to either go look at our archival description from the Wikigraph and then go in and look through our inventories. Or you could go look at the properties for that item. And then also you can see our ARC here. Archival resource keys are the persistent identifiers we use to document our agents, document our concepts, and document our local concepts, and then document our digital objects. So those are the URIs that describe our nodes. With the back button, you can always go back and you could just explore in this stuff and see how these collections are interconnected. You could do the same thing with people and corporate bodies. Hey, there goes me in here holding the Baby Sharks book. So for example, the best way to search for people would be by occupations. For example, politicians. And you could zoom in with your mouse, hover, and you can look at these people. And these are all the different people we've added in Wikidata who are related to politicians. You can also see other professions. This is the profession occupation attribute. So this is how these people are connected by occupations. Now, if you click the X and go out of it, you can also click on places of birth, places of death, and like what Andre mentioned in the config files, if you had other relationships, you would be able to go ahead and modify it and add it. For corporate bodies, you can look by business names or other details like, say, casino. So we have, here goes some Las Vegas casinos, El Cortez, the Flamingo, the Moulin Rouge, Carver House. So you can see these different casinos and stuff like that. And then there's the full information. Also, I didn't mention in people, if the people have oral histories or have manuscript collections, there are some links that'll get you to those as well. And then we have, let's see, corporate bodies. We don't have a wildcard to get everybody, but playing with the graph, I noticed if you press A, it's the most common letter, you'll get a higher data set. And I'm probably pushing the system, but that's okay. It takes a little while for these to render this many nodes. Once you start getting in more nodes with a lot of interconnections, it gets a little bit complex. So we wanted to just figure something where you could click. So Ed Hewing, you were able to click on the person. So if you just wanted to focus on one person, and if you want to go back, you can always go back. So this is pretty much it as with the functionality right now. So let me take you back to so moving forward, there's still some core functionality that needs to be built. This includes establishing an appropriate open license agreement or rights statements. We want to integrate GIS visualizations using like the OpenStreetMaps, because those corporate bodies, some of them have coordinates in there. So we could be using maps, and that will be coming next. And then thirdly, we're going to integrate in the next iterations, integrate faceted filtering. So for example, on the home page, somebody who doesn't know anything about your Wikiframe, what data you've modeled, what data you have, you could just be able to filter, say, by like P31 or like instance of, that's what the P31 value is. For those of you not familiar with Wikidata, that would have been the equivalent of, say, RDF type. So, and in addition, I would love for us as a community to further develop and share governance on this product. There's been a lot of activity to create Wikidata, but what now? How are we going to make sense of all this library linked open data? The community can get involved now. And we encourage you to fill out a brief user feedback form while playing with Wikiframe. And the feedback form is anonymous, and it can be found at this link. Put it in the chat. And on that note, that is it. So I'm happy, me and Andrea are happy to take any of your questions. And thank you.
Thanks so much, Darnell and Andre. This was great. And there's a lot of assignment I see on Slack. We have quite a few questions, but we are short on time. So Christine is just going to read a couple of questions, but the conversation can continue on Slack. Remember, hashtag 2023_LD4.
Yeah, so
/com.
So for those who are still staying on and not hopping to the next session, there's some really great questions in the chat and a lot of enthusiasm. So Zoe Dobbs is asking, would the entire infrastructure need to be overhauled to work on top of a different triple store, or could that be possible with probably many adjustments? I know it's called Wikiframe, but just wondering.
You know, I mean, technically in theory, it could, you know, but the mapping, you would have to do completely different mappings. You would have to include completely different namespaces potentially and stuff, since we're working with this open data and stuff like that. It would probably be easier for the open data because, you know, really this application is nothing without the data. So, and we want it to be open. So something like this could probably be modified for maybe say like a DBpedia serialization or, you know, something like that. But it would take a lot of remapping, a lot of rewriting SPARQL and stuff like that.
Yeah. Thanks. And then there was a question about where the code is, but I figure you can answer that in Slack. And then there was a question from Dorothea Selos asking, this may be too technically in the weeds, but I'm curious about caching Wikidata as tables. Is that how Wikidata's data model works internally, or is there some RDF triple wrangling that has to happen to represent Wikidata tabularly? Goes on to say, cards on the table, I happen to think RDF's triple store is a massive problem for its adoption. Table structures rule the world. Table structures won. Let's revise RDF to match. So so if there's a decent way to represent RDF as tables, which I feel like is anyway, the discussion goes on, but so feelings about tables and caching.
So we use tables. So this is all the SPARQL that I've written is graph to tabular form. So there are no construction clauses used in any of this. We've defined variables and we select it. And so the representation is flat. We decided to do that because it's easier to manipulate. Eventually we will have a download button where you'll be able to download your data in either JSON or CSV, similar to what's already available with the Wikidata query service and stuff like that. But so far, yes, we have not done any I haven't written any construction clause for Wikiframe because we want to pull the data back. We're not writing using this tool yet. So
So couple more, like actually, there's a thing about permissions on the link that you shared. So I assume you can follow up on that in Slack. And then one last thing, Stephen Folsom is asking, the donut charts and some of the visualizations had me thinking this could not only be used for discovery / navigating collections / entities, but also for analyzing productivity and prioritization of data cleanup, data creation / cleanup work. Has what you have seen in the visualizations informed where to focus data creation efforts? Love this question.
Yes, Steve. So just by testing it before we presented it over the last month or so, we have noticed with those graphs, hey, why is this node disjointed? You know, say for like, oh, this person, we forgot to add the occupation for, say, the people in the people graph, right? So this has informed data cleanup, not only in Wikidata, but also in our portal. As I showed, we use our ARCs. That will also notice this, like we were able to identify, oh, maybe this label had a misspelling, had a typo. The diacritics may not have appeared or rendered properly. So we've been able to go back and clean up the data in our portal, and using this as like a part of a mechanism to be more dynamic in our data quality and data cleanup and stuff like that. So
awesome.
Yeah, this is a good tool for that. And we have thought about ways, we are thinking about ways, and maybe even within Wikiframe, being able to update the Wikidata through Wikiframe as well. So we have been thinking about that, but we're still building out core functionality.
Cool. All right. I'll hand it back to Paloma to wrap this up.
Well, thanks so much again to the speakers, and thanks to all the participants. And please consider continue the conversation on Slack. There's good threads going on. And thanks so much.